Hello, everyone. My name is Evan Snyder, and I'm enrolled in Physics 114 in the spring of 2026 at South Seattle College. And today we're going to talk about acceleration. This is Cricket. Cricket's my dog. I'm a little biased, but I think she's pretty amazing, and she's pretty fast, and she's pretty cute. And speaking of fast, every time we're at the park, when I throw the ball for her, everybody comments how fast she is. So, using physics and using the Logger Pro, we can see exactly how fast she is regarding her acceleration. We need to keep in mind that acceleration is the rate of an object's change in velocity over time. Basically, it's Cricket's ability to increase her speed, and typically it's expressed in meters per second squared. So we're going to use Logger Pro to determine her acceleration while chasing the ball in a one-dimensional movement, and then we'll do the mathematics equation as well. So we're going to find Cricket's acceleration, and we can see the formula for the acceleration is basically the delta of velocity, so the change of velocity over the delta of time, right? So it's that change of rate of velocity over that set amount of time. We're referencing the college physics books, A Strategic Approach, 4th edition by Randall Knight, Brian Jones, and Stuart Field. And we're also going to use motion diagrams through Logger Pro to help solve as well. And in particular, we're focusing on chapter 2.4 regarding acceleration, describing the motion, and the example in the book. Logger Pro is a software program that we can use to calculate the velocity from the position data and then decide the acceleration from the slope of the velocity versus the time graph. And it'll also provide the data that we need to calculate the equation as well. So here's a video that we're going to use. Again, I'll play it again. And again, I feel like Cricket's pretty fast regarding acceleration. So let's try it out. So let me pull up Logger Pro. We're going to go ahead and insert that video. So we're going to go to Movie. We're going to go to Desktop. And we're going to find that video that we want, which is going to be in Physics Video. And we're going to insert it. Well, thanks. There it is. We're going to go up to Page, and we're going to go to Auto Arrange. That just kind of helps make it look a little bit better. If we come down here, we click on this. This gives us our information that we can use as far as establishing our parameters. And if we go up to this one here, we can set the scale. And before I threw this ball, I put a yardstick down. So we can measure this yardstick here, and we can set that measurement in that video is 1 yardstick, 1 meter. We're also going to come up here. We're going to set our origin, and that's going to be where Cricket is. And then we can go ahead and use this button up here, which is adding the point. And every time we click, it'll add the point, and that's going to provide us the data in the graph. So I'm just going to start right here. Let's go with Cricket's front. So it's going to take her a couple times to spin around. So there isn't going to be much change. Every click will advance a frame. So I'm just going to keep clicking. Okay, she's turned. So now I'm just going to go and click at Cricket's front. For every frame, I'll try and get on her snap. We're just going to keep clicking through this less than 3-second video. But it seems a little bit longer when we click on it. But again, this is going to give us that data that we need to determine her acceleration. Almost there. All right. So there we go. So a couple things that we can look at here. We see this graph here, and we see that it's going up on this side, which means that she's having some forward momentum. It also means that she's increasing speed. I'm just going to go back to page auto range to kind of button it back up. Down here on this left-hand side, through our video analysis, it's going to show us our data that we're going to use for our calculation. And we're going to look at that x velocity. Through that x velocity, we can go up here and we can do linear fit. And we can see that line, again, that increase in the motion there. So before we do the calculation, we can look at this graph because Logger Pro can show us that this slope right here, 3.611 meters per second, that slope, that area underneath that acceleration graph, which in this area represents the change of velocity under the time frame, right? So we've got the time frame and the change of velocity. That slope is going to give us our acceleration. So we're about at 3.611 meters per second squared. And that's the information that we can gather from this graph here. On the left-hand side down low here, this is that data that we're going to use that we can put in the calculation. And we can scroll down and we can see the very end right here as well. So again, this is what Logger Pro looks like. Now we're going to minimize this. We're going to take a look at it. So again, we're going to interpret that graph a little bit, right? So we can see that she's changing speed, right? She's accelerating up and she's moving to the right, which indicates forward momentum. As we discussed through this graphic here, we can see that the rise and the run, that gives us our acceleration, that slope. And again, that area underneath that acceleration graph represents the change in velocity over that time interval. If we do the numerical calculation, we just need to remember that again, acceleration is the rate of change in velocity over time. So we can see here that from the beginning, Cricket's initial velocity was 0.719. The final velocity is 8.461. So again, we're looking for the delta in velocity. So the delta of the velocity over the time interval. And the time starts at 0 and it ends at that time. So in conclusion, we can see through the graph and both through the calculation that Cricket's acceleration is 3.56 meters per second squared. So that means that for every second she changes speed by 3.569 meters. So again, that's that increase in her speed, her acceleration. If we wanted to convert that to miles per hour for fun, we just take that final meters per second squared and we times it by 2.237. So her acceleration is about 7.9 miles per hour, which is pretty good. You know, that makes sense. Thinking about myself running as fast as I can, I'm nowhere even close to 7.9 miles per hour. And if I picture a car, you know, a little less than 10 miles per hour, that kind of makes sense. Sadly, if I compare it to the average dog's accelerations, we can see that a greyhound is 20 meters per second squared, which is pretty fast. And that average dog is about 2 to 4 meters per second squared. So Cricket's average, but she's more towards the upper end. So I still think she's pretty special, even if she's not greyhound fast. So again, thanks for walking through acceleration with me. Taking a look at Logger Pro, which is a useful tool that we can use for calculating all sorts of different physics-related calculations and equations. Thanks for your time, and I'll talk to you later.